This test is the two-way within ANOVA. When do you use the two-way within ANOVA? When you have two independent variables with two or more conditions each. Both independent variables are categorical. Both independent variables are a within design. Of course, one continuous dependent variable. I want to teach you a little about two-variable ANOVA notation. We use the phrase 2 by 2 within ANOVA to indicate that independent variable 1 has two levels or groups, and independent variable 2 has two levels or groups. The first number indicates the number of groups in independent variable 1. The second number indicates the number of groups in independent variable 2. Imagine we had 3 groups for independent variable 1 and 2 groups for independent variable 2. We would have a 3 by 2 design because there are 3 groups in independent variable 1 and 2 groups in independent variable 2. If we had 2 groups in independent variable 1 and 3 groups in independent variable 2, we would have a 2 by 3 design. In this video series in this class, I am only going to use 2 by 2 designs. If you find yourself in need of an analysis with larger designs like a 3 by 2, we should do this together as it gets more complex. In general principle, when you have 2 independent variables, you are testing 3 things at the same time. Number 1, you test for what is known as a main effect of independent variable 1, which is, in this case, is simply asking, are the 2 means associated with independent variable 1 different from each other? Number 2, you are also testing for a main effect of independent variable 2, which is again simply asking, are the 2 means associated with IV2 different? And number 3, you get an interaction test, which is a test of moderation. Remember, moderation is testing if the effect of IV1 on the dependent variable is different at the different groups or conditions or levels of independent variable 2. In this design, it is important to understand that each participant will give you 4 separate measures of the single dependent variable. I like to think of experiments as experiences. Different conditions or groups are different experiences. The control group is a different experience than the experimental group. To extend this analogy, level A of independent variable 1 is a different experience than level B of independent variable 1. Likewise, level C of independent variable 2 is a different experience than level D of independent variable 2. In a 2 by 2 design, there are 4 possible experiences. One experience is level A of independent variable 1 plus level C of independent variable 2. The second experience is level A of independent variable 1 plus level D of independent variable 2. The third experience is level B of independent variable 1 plus level C of independent variable 2. And the fourth experience is level B of independent variable 1 plus level D of independent variable 2. You can see this outlined in that table below. In a within design, participants will have all 4 experiences, and after each individual experience, participants provide a measure of the dependent variable. Thus, in total, each participant has all 4 experiences and provides 4 measures of the single dependent variable. So in this data file, you can see that we have 4 columns for the one dependent variable, with each participant providing 1 measure of the dependent variable for each of the 4 experiences, leaving you with 1 participant ID column plus 4 measures of the same dependent variable, 1 measure for each of the 4 experiences. 2 by 2 equals 4. Experiences. In a 2 by 2 within design, each participant has 4 experiences and provides a dependent variable measure after each individual experience. Let's see what buttons we click after we have the data entered. Hit enter. Check combinations. Let's see that again. Hit enter. Check combinations. You can also click those two in individually. For the main effect of independent variable 1, we are asking, are the means within independent variable 1 different from each other? The pattern suggests that group A has a lower mean than group B. P-value is less than 0.05 and is significant. Eta squared suggests that independent variable 1 causes 99% of its unique share of the dependent variable. There is no confidence interval, so our interpretations are limited to the sample effect size, which this one is large. Are the means within independent variable 2 different from each other? The pattern suggests that group C has a lower mean than group D. When we look at the independent variable 2 line, we find that the p-value is less than 0.05 and is significant. The eta squared is 0.99, which suggests that IV1 causes 99% of its unique share of the dependent variable. There is no confidence interval, so our interpretations are limited to the sample effect size, and this is large. Does independent variable 2 moderate independent variable 1? Let's look at the pattern. Is the effect of independent variable 1 different at the different groups of independent variable 2? One group of independent variable 2 is condition C. This condition is represented by the blue line. When we look at only the blue line, that is only condition C of independent variable 2, we see that the effect of independent variable 1 on dV is minimal. Group B is slightly larger than group A. The other group of independent variable 2 is group D, represented by the yellow line. When we look at only the yellow line, that is only condition D of independent variable 2, we see that the effect of independent variable 1 on the dependent variable is large. Group B is substantially larger than group A. So the pattern suggests that the effect of independent variable 1 on the dependent variable is moderated by independent variable 2 because the effect of independent variable 1 on the dependent variable is different for each line, and each line represents a different group of independent variable 2. I know that was a mouthful, but from now on you can just say your two lines do not have the same slope. That is telling us the same thing. Next, we look at our p-value. We look at the interaction line right there. Independent variable 1 times independent variable 2. That's the moderation line. Our p-value is less than 0.05, and this is significant. While we do not have the population effect size, the sample effect size is large. The interaction accounts for 98% of its unique share of the dependent variable. You may be asking why the three percentages do not add up to 100%. That is because each effect has its own unique share of the dependent variable. If you want to learn more about this, please reach out, but thinking about this question too much will make your brain explode. Post-hoc tests are sometimes needed for an ANOVA. If you need a refresher, you may go back to the one-way independent variable ANOVA videos. However, no post-hocs are needed in 2x2 designs because the first main effect of independent variable 1 is only comparing two means. We know which two means are different. The same goes for independent variable 2. We are only comparing two means. We know which two means are different. Mathematically, the test of moderation, the interaction, is a test of line slopes. If two slopes are different, we know which two slopes are different. So no post-hocs are needed for 2x2 ANOVAs. However, if you do find yourself running a 2x3 ANOVA or a 3x3 ANOVA, I am confident you can figure out what to do next by looking at the other Jamovi tutorials. However, it is the most complicated experimental analysis you can run. So if you are my student on the ground and you find yourself in this situation, please find me and let's do this one together.